Hello. In this video we are going to talk about the FAT system, file allocation table. In our previous videos we talked about different possibilities for memory management and different more simple file systems. Here we will demonstrate the usage of the FAT file system on the ESP32 in the ESP IDF 5.0 environment. All the system is based on the VFS, virtual file system, which is internal module inside the ESP32, which enables us connection to the different file systems on the higher level. A quick comparison. First, we started with the NVS memory management, which is good for operating some kind of parameters and so on. Then we demonstrated SPIFs file system, which is relatively small file system for the Flash installations and enables us to control videos and files and so on. But those systems cannot support directory support, the lack of it, and also they are not common in the PCs or other operating systems. Now we are going to talk about FAT operating system, which was widely used in different computer systems, including PCs. Here we see that the system is much more memory consuming, but it enables us a directory support, and it's a full functional file operating system. First, we'll go to our sources. Like Wikipedia, you have a very extensive material regarding the file allocation table FAT system, and you can read it and so on. Inside Espressive, you have a FAT system support explanation here, which I found not so clear. It's pretty brief, and the examples here are not so simple to make it work. We took one of those examples, simplified it, and demonstrate in this video how you actually can install it on your ESP32. Additionally, I want just to show you the playlist in this video channel, which called Free RTOS ESP IDF Memory Management. And you can see that you have different memory management videos here, but relatively to what we have is the first and the second videos, which talk with the second video which talk about NVS. You see here NVS memory management, and shows how to store a string or an integer 1 and 2, and the third video is regarding the SPIF system. Now we are talking about the fourth video, which will talk about the FAT. As always, we go to the GitHub repository. Inside repositories we have FAT here, and here we have two files, the C file and the partition table example. And also in the read file you have an explanation, because the installation of those files requires a small configuration in the Menuconfig, so it's explained here. So what we basically do is put the partition file inside our root directory above main, and copy paste the C file inside our new project. So what we have here is this file installed here. Now just please look on the project. You have a proj for the file is here inside main, and you have partition CSV outside main. It's an important distinction. If we look on our partition table, the numbers here are much higher than the SPIF's file system, and I had many difficulties to find out that the errors that I have is because I didn't allocate enough memory here. So the numbers here are, maybe they are not the minimal possible, but they're significantly bigger than in the SPIF system, and those numbers are important in order to make the program work. So going back to the program, first we have to do 2 installations. Let's go here and here. You see, first we already installed the partition SCV partition file, and now we're updating the partition table and serial flash configuration. Okay, let's do it. Menuconfig, we'll run it, and inside the partition table we are going to the partition table first one, and here is a single factory app, no OTA, which is not enough for our memory requirements. So we're using custom partition table CSV. You can see it here. We have this one chosen because we have a partition CSV file. Additionally, escape. We have to update our serial flash configuration. In serial flash configuration, here the flash size by default is 2 megabytes, when in our case, in our board we have 4 megabytes. Okay, let's save it and quit. Why 4 megabytes is important? Because if I'm going back to the partition table and sum up all those memory requirements like here and here, you see it's much more than 2K. So we have to define it previously in order to make it work. Now let's run the program, flash it, build and flash it, and while it's compiling, go over the program. Standard includes, which include the FAT include and the VFS include for the basis of the operation system and the FAT file management system. And we have a basic definitions, and inside the program we have 3 steps: setup file system, write file, read file, and then we show it on the screen and unmount the FAT system, which is written in FatFs format. Okay. Regarding the differences for the standard example, this option was updated to more relevant file, which is used in the ESP in the ESP 32 ESP IDF 5.0. So this file is a little bit different, and also we erased some error managements just to make it look more simple to understand. What we would expect is first mounting the file system, after it opening a file, right inside the text file this text file, and this sentence, this one, and then read this file and read this sentence from the file written using ESP IDF. Okay, let's see. Okay, the FAT system was mounted. Then we opened the file and the file was written successfully. Now we're reading the file. Data from the file is the line that we have written here, this one. And now we are mounting the system. So here we demonstrated the usage of the FAT file management system on the ESP32 board by using ESP IDF 5.0. Thank you.